Good day everyone, I'm Pintor. So I'm gonna show you my code. This is the structure of my code with 116 lines. So today I'm gonna show to you the flow and the illustration of the code of how it works behind the scene. So let's try to run the code first. So let's run it. So as you can see, we have the push option, pop option, display, the stack option, and to terminate the program option. So let's input first the elements or data into the push option. So pick up push option. Okay. So example, I'll input 90. So in order to connect this into a real life situation, I'm gonna use the example of stacking a pile of notebooks or books. So into the data to stack. So in the first data I have the 90 pages of notebook, and the second data will have the 80 pages of notebook, and the third data will have the 70 pages of notebook, and then 60 pages of notebook, and then 50 pages of notebook. So the data are inputted into the program, and let's try to see if they are truly recorded to the program, if their data is saved in the program. So let's display the stack. So as you can see here, it was displayed 50, 60, 70, 80, and 90. So you may be wondering why 50 is in the first, is inputted first. So stack data is LIFO, or which simply means that what you inputted last will be outputted first. So we will go back. We will illustrate that more in the illustrating part. So let's go to the pop option. So as you can see, pop value 50 in stack. So the 50 pages notebook has been popped out in the data. So as we display the data in my program, you can see that the data that are now been showed are the 60, 70, 80, and 90. The 50 has been popped or deleted. So as you can see, let's go to the illustration part. It is understandable enough, I think. So let's close the program by terminating it, which will simply exit the program by choosing the option 4. So okay, so let's go to the illustrating part. So as you can see here, I already inputted some of the valuable illustration of my program to save some time, because I have a very low internet connectivity here in our place. So to make my video short, I'll just input this a couple of minutes ago. So what I have said earlier, stock is a LIFO, or the last in first out data structure, which simply means that what you inputted last will be outputted first. So as what you can see here, it is the head, then this is the data and the address of the node. So we inputted 50 less in the program, so it will be shown in the illustration as 50. It will be outputted as 50 is the first node, because we inputted it last in the inputting part. So how it works. So at first there are no nodes. So in order to create a node, let's just copy this. So I'll just simply use the right click and the right click pasting part, because my control K is not functioning, so I cannot control C and control V. So in order to push a new data into this element, we simply create another node. So this is what happened when we insert or we push a new node to the linked list. So here is a new node. So this program will only push a new node to the first node, not to the last node, because it will take some time that will cause memory. So to save memory, we just inputted it to the first node. So as you can see, head is equals to the 100, so pointing to 100 at address, so which is the address of the new node. So in order to push a new data or the new node, so we simply get this one by deleting it, delete, and then we simply add a new address in the head. For example, we have the address of 250. So this is the address of the new node that we just created. So let's just paste that and copy it. Copy. Paste. So okay, so it's 250. So in order to push this to the first node, we simply create the erase this line, and then this example, the data of this new node is let's say it's 55. So 55. So that's what we inputted last in our when we input data. So 55. So and the address, its pointing address is 100. So which simply means that the head is now pointing to this node, which will be the first node because we inputted another node, and this node will be pointing to this second node. So a little bit of distraction here, sorry. So as what you can see, this is now our first node, and then the first node will be pointing to the second node, which as what you can see here, the data address or the address of the head is now changed to 250, which is the address of the first node. So that's how the pushing part works behind the scene of the program. So again, if we input another data, we simply another data or another node, this will change to the exact data, example 300. So this will change to the data of 300, and it will just simply repeat the process of creating a node. So that's how pushing part, the pushing part is working behind the scene of the program. So let's go to the deletion part. So just copy paste it again. Okay, wait a minute. So okay, copy and then paste it here. So in order to delete a node which will be deleted in the first node, because deleting in the last element of the node, it will take a period of time and it will cost some memory. So in order to save memory, just I decided to delete the first node. So in order to delete the first node, it will just reverse the process. This will be deleted, and this will be deleted because we delete the we terminate the first node, which is we pop it. Okay, we pop the first node, so this will be terminated. This will be terminated. Wait, this will be terminated. And then this address, the 100 address, will be placed here because we pop the 250 address or the first node of the program. So as what you can see, to push to summarize it, as we push a node to its to a new node to the first element. For example, we have a 100 address of head here, which will point to the first node. To insert to push a new node, this will the head will change to the new node address, which is 250, and then the new node which is created with the data and the pointing address to the next node will be created. So as what you can see here, 250 is now the new address because we push another node or another node to the element or to the linked list. So this head will simply locate to the new node or the first node which have the 250 address, because the head is now pointing to the 250 address now, and then we the address of the first node before will be placed here to the pointing address to the second node. So that's how pushing works in pushing a node to the linked list. So in the deletion part, we'll just simply reverse it by replacing 260. The program will replace 260 to 100 because we delete the new node, the other node which have the data of 55 and the address of 250. So the 100 address will simply go back to its head, and then it will find the address of 100, which is the 50, which have the data of 50, and then we'll just simply continue the process. So I think that's it. That's how the pushing and popping part works in linked list. So I hope that my illustrating example is good enough to make you understand of how it works behind the scene. Let's move on to the queuing part. So good day again, everyone. Let's move on to the queuing part. So as you can see, this is the program of queuing and queuing. So to run it, let's try to run this if it actually works. So okay, so waiting for a bus. So proxy bus liner. So waiting for a bus. So this is for example, this is taken to a real life scenario where you are falling in line for to get on board the bus. So for example, you have fallen line in line number 4. So just input 1 and input line number, and you have fallen in line into line number 4. So data is saved. You are now lining up in line number 4. So in order to know that you're lining in line number 4, let's try to display the line info. So expecting a line for boarding in 4 proxy bus liner. So you are expecting to get on board if line 4 is done queuing your the line. So in order to if you're done falling in line number 4, just simply wait 2 for boarding, and now line number 4 is now on board. And if I try to display that, there are no people lining up. So that means that line number 4 is now done lining up for the bus. So let's try to input 2 again. So your line is done. Welcome aboard. So this simply means that you're on board and is now waiting for the bus to go. So in order to explain this, illustrate this code, let's go to the paint. So okay, so these are the last example of stacking. So let's move on to this part. So in the first part, as what this is an illustration value. So example. So in this part, we have line 1, line 2, line 3, line 4, and line 5 in a linked list form. So as what you can see, you have inputted for the line 4. So your data is stored here in line 4. So when you input line 4, your data is stored in this linked list, and then in order to display or to know where you are aligning for, the program will start to find the line number that corresponds to the number that you inputted in the line info. So with the command of point to 10th net next, the program will start to find your line like 10th, then next, 10th, then next, and then until it finds its value of the value of line number info. So that's how the line value is stored, and how it find and display the line value of your line info. So in order to board, it's just the same logic. Line number is that is being like deleted to the linked list, so that the linked list will be updated that your line number is done and you're now on board. So the program is just like the stack popping logic. It will simply delete the value of the head, because we are expecting in this part that the line 1 is already done, line 2 is already done, and line 3 is already done. So in order to do that, it's just same here, where the head is the first node in the element is deleted, and then it will go to the next element, which is the node 2. So just simply like this. Head number will let me copy this first. Okay, so this will change to, and this will be deleted because it's already done. Delete, and then delete. Then the new head will be the new head address. The new pointing address of head will be 200, pointing to the next node, which is 200, which is the second node before, with the data of 2 on the address of 200. So after the first line is done, it will simply delete the first node, then until it gets to your line info. So next step, it will just simply repeat the steps until it gets to your line info. Like this will be deleted, and then the head number will be changed to 300. And then the head is now pointing to the third node, which is the third node before is now the first node, because we deleted the first and second node, which is the first and second line, because the waiting is over and they can now simply go and move on to the next line until it gets to your line info. And then if line number 3 is done, they simply delete it again. Then the address value will be changed. Okay, address value will be changed to 400, simply pointing to your line info. Simply pointing to your line info, which will receive the data and then output in the program that you have you're finally on board. So when you're in line, the line number 4 will be deleted, then output that you are in. Let me just delete this in order to make it more cleaner. So until your line number is now over and lining up, then it will output in the program. It will output that you're finally on board. Welcome aboard. So that's how the implementation work, or the logic work in the queuing and uncreating part of the program. If you're lining a bus and waiting for your turn to waiting for your line to be over and queuing. So that's it for today. Thank you for listening, and I hope that I have given you valuable information about linked list, stack, and queuing. Thank you, and God bless. Bye.